Hello class. In preparation for the quiz tomorrow, I just thought I'd review over permutations and combinations and factorials and all that good stuff. To get started, you need to understand factorials and how they work. It's really simple. It's written as a number with an exclamation point. Here we have 5. 5 factorial would be 5 times all the numbers before it. So 5 times 4 times 3 times 2 times 1. It's that easy. Here we have 8 factorial. 8 times 7 times 6, and it keeps going until times 1. Now, permutations. Permutations, they're selections of items where order is important. So in this case, if we were to have 2 items, A, B, this would not be equal to B, A. That's a good way of, this is how I remember it. It's a good way of thinking about the difference between permutations and combinations. Permutations, AB does not equal BA. I'll come back to that later. Let's say we have the permutation of 6 objects taken 3 at a time. So the formula for a permutation is n, which is the original amount of objects, so in this case 6, n factorial over n minus r, in parentheses, r being the amount of objects you're taking out, so in this case 3, factorial. So in our problem here, the permutation of 6 objects taken 3 at a time would be 6 factorial over 6 minus 3, in parentheses, factorial. Now you just simplify from here. So this simplifies to 3, so 6 factorial over 3 factorial. Now there's another way you can simplify this. You can write it out as 6 times 5 times 4 times 3 factorial over 3 factorial. And you can cancel the 3 factorials out. Now all that you have left is just 6 times 5 times 4, which works out to 30 times 4, which is 120. So the permutation of 6 objects taken 3 at a time is 120. Let's do another one. Let's do the permutation of 8 objects taken 4 at a time. So the permutation of 8 objects, taken 4 at a time. So like I said here, you'd put n on the top, which is 8 factorial. Whoops, that's not an exclamation point. 8 factorial over n minus r. So 8 minus 4 factorial. So 8 factorial over 8 minus 4 is 4 factorial. We could rewrite this as 8 times 7 times 6 times 5 times 4 factorial over 4 factorial, and cancel these out. Cancel the 4 factorials. So now all that's left is 8 times 7 times 6 times 5, which, if you work it out, well, let's do it right now. 56 times 30, which, using the trusty calculator, is 1680. So equals 1680. This is the permutation of 8 objects taken 4 at a time. A word problem example would be something like 10 people are running for an office. Let's say you have president, vice president, treasurer, and I don't know, let's do like representative or something. Let's do, representative. So you have 4 positions, 4 different positions in a government. And there's 10 people that want to fill these 4 positions. So there's 10 people, which in this case would be the n. So you would write 10 factorial on the top. Actually, no, hang on. Let's pause right there. You can, in a problem like this, where it's talking about positions, if you have one person that is the president and one person that is the vice president, okay, that's one thing. But if you have the same person that was president now is vice president, but the person that was vice president is now president, this goes back to what I said earlier about AB does not equal BA. This is how you can tell whether or not it is a permutation or a combination. Because in this case, let's say person A was president and person B was vice president, it is not the same in this case if person B is president and person A is vice president. It is not the same. So this is how you can tell that anything that is not equal, in this case, is a permutation. So going back to this right here is a permutation because, like I said earlier, order matters. It's not the same thing if you're president or if you're vice president. So, like I said earlier, we have 10 people that want to fill in these 4 slots. And how many different ways can that be done? Well, let's write it out with a formula. So 10 factorial over parentheses 10 minus 4 factorial. All right, let's simplify. So 10 factorial over 10 minus 4 is 6 factorial. So 10 times 9 times 8 times 7 times 6 factorial all over 6 factorial. You can cancel the factorials, and we're left with 10 times 9 times 8 times 7, which, if you plug into your calculator, is 5,040. There you go. That's how you do permutations. Now on to combinations. Combinations are very similar. They're very similar. So, a combination is a selection of items where order does not matter. So unlike right here, where AB does not equal BA, in this case, let me get a piece of paper, AB does equal BA. So for example, let's say there are 20 classmates, and they're being put into groups of 4. It doesn't matter if pupil A, B, C, and D, if these people were chosen to be in a group, or if the people C, D, B, A were chosen to be in a group, because they're the same group of people. So this is when you'd use a combination, because order does not matter. If you have 2 people in a group, it's the same as 2 people in a group. So the formula for this is just like the permutations one, but with one extra little variable. So we have n factorial on the top, all over, and here's where it gets here's where it's different. You put r factorial here, and then the parentheses n minus r factorial. So in the example earlier of was here 6 and 3, if we plug that in here, we would get 6 factorial over, remember that 3 would be put here as a factorial as well, so 3 factorial parentheses 6 minus 3 factorial. Sorry if I go off camera. So this little extra 3 factorial is this is what distinguishes it between a combination and a permutation. So let's solve this. All right. So 6 minus 3 is 3, so 6 factorial over 3 factorial times 3 factorial. So remember what we said earlier, you can do 6 times 5 times 4 times 3 factorial over 3 factorial, 3 factorial. I wonder how many times I've said factorial in this video. So you can cancel out some of the 3 factorials. So now you're left with 6 times 5 times 4 over 3 factorial, or 3 times 2 times 1. And unfortunately, there's not any other ways you can simplify this on paper, so you're just going to have to solve this out. So 6 times 5 is 30, times 4 is 120, over 3 times 2 times 1 is 6. 120 divided by 6 is, oh, math don't fail me now, 20. So in this example, where n is 6 and r is 3, when it was a permutation, you would get 120. But because this is now a combination and you have this extra r factorial on the bottom, the combination is now 20, just normal 20, not 120. Those are the key things that distinguish a combination from a permutation. It's just this little variable right here, this little number. Now, a word problem. This is one of the things that Sister said would be on the test. Let's find the number of distinguishable, find the number of distinguishable permutations of the letters connection. Okay, so, here. So how many ways can we rearrange the word connection? So the first thing that we have to do when we're doing a word problem is we have to see and find whether or not there's repeats. In this word, we can see that N repeats once, twice, 3 times. So there's 3 N's. We can also see that there's 2 C's and 2 O's. So we have 3 N's, 2 C's, and 2 O's. So with that in mind, we draw a little dividing bar, the dividing thing, and we put 3 factorial because there's 3 N's on the bottom. Put that on the bottom. We see that there's 2 O's, so we put 2 factorial on the bottom. And we see that there's 2 C's, so we put another 2 factorial on the bottom. Now we count up all of the letters in the word. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 words. It's 10 letters. So we put 10 factorial on the top. Pretty simple. All right. Now that we have this written out, we can start solving. So, oh boy. Okay. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 3 factorial. You can just put that. Times 3 factorial all over 3 factorial, 2 factorial, 2 factorial. And because we have a 3 factorial here and 1 here, we can cancel these out. Now we're left with, let me go back to here, 10 times 9 times 8 times 7 times 6 times 5 times 4 over 2 factorial, 2 factorial. Now, unfortunately, like I said, we're going to have to simplify this manually. It's pretty easy, though, because 2 factorial is just 2 times 1, which is just 2. So 2 times 2 in this case would just be 4. So we can just scribble these out and put a 4 here, because that's what that equals. And now if we take out the old calculator and type in 10 times 9 times 8 times 7 times 6 times 5 times 4, and divide the answer by 4, we get 151,200. So the total ways we can rearrange the word connection are 151,200. We can do it again with another word. Let's do the word between. B-E-T-W-E-E-N. So, like I said before, we draw the little fraction bar, and we see how many repeats there are. In this word, there's 1, 2, 3 E's. So we put a 3 factorial on the bottom for that. I don't see any other repeats. If you see one, put something in the comments or something, but I don't see any other repeats. So we count up the total amount of letters, 1, 2, 3, 4, 5, 6, 7, and put that on the top. 7 factorial. Now we simplify. So 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. We can cross these out, and we're left with 7 times 6 times 5 times 4, which, going back to our calculator, is 840. So we can arrange the letters in between 840 different ways. So let's do a problem where you have to figure out whether it's a permutation or a combination. So let's say there's 15 students. So 15 students. The teacher is arranging them into groups of 3. So there's groups of 3. Is this a permutation or is it a combination? Well, going back to our first paper here, we can see that if the grouping AB does not equal the grouping BA, then it is a permutation. But where did I put that? But if AB does equal BA, then it would be a combination. All right. So let's take the example of students, for example. So we have 15 students in groups of 3. Let's say we have a student named Jimmy and a student named, I don't know, Bob. So let's say that Jimmy and Bob were chosen to be in a group. So we have Jimmy and we have Bob. Now let's say different groups were chosen. And this time, Bob and Jimmy were chosen to be in a group. Well, they may be in different orders, but it's still the same group. And because, in this case, AB equals BA, this is a combination problem. So, the combination of 15 and 3. All right. So, let's go back. Let's go to this example. So now that we know it's a combination, let's write out the formula. So, n factorial, what's the n here? The n is 15. So 15 factorial over r factorial, so in this case 3, so 3 factorial, parentheses, n minus r. So 15 minus 3 factorial, so factorial. All right, now that we have this, we simplify. So 15 factorial over 3 factorial, 15 minus 3 is 12, so 12 factorial. Now we can extend this out, so 15 times 14 times 13 times 12 factorial, because after that it's just 12 factorial, because 12 times 11 times 10 times 9, over 3 factorial, 12 factorial. So we can cancel the 12 factorials out, and we're left with 15 times 14 times 13 over 3 factorial. And 3 factorial is pretty small, it's just 3 times 2 times 1, which is equal to 6. So, taking back our calculator, if we just type out 15 times 14 times 13, divided by 3 factorial, which is 6, we get 455. So there are 455 different ways you can have groups. From 15 students, you can have groups of 3. All right, let's do another problem. So let's say that we're trying to find how many different 2-letter arrangements we can make out of the word cat. Now, like we did before, with, let's say, the word connection here, there were repeats. But because there aren't any repeats in the word cat, we don't have to worry about doing the factorials on the bottom like so. We need to find out whether this is a combination or a permutation. Now let's say we have the 2-letter grouping CA and the grouping AC. As far as the alphabet is concerned, those two are not equal. So if we look at the rules here, it is a permutation because AB does not equal BA. It's just like CA does not equal AC. So this is a permutation. Now if we put the formula here, we have the total amount of letters, n, so 3 factorial, over n minus r. And because we're trying to find 2-letter pairings, the r is 2. So 3 minus 2 factorial. Now, simplifying this, we get 3 factorial over 1 factorial, which simplifies to just 3 factorial, which 3 times 2 times 1 is 6. So there's 6 different ways you can arrange the word cat. Now that's just about it when it comes to permutations and combinations. Sometimes you're gonna have problems like how many different pizza varieties could be created if there are 2 choices of crust and 2 out of 3 possible toppings. So when we do that, in this case, order doesn't matter because you can have thick crust and you can have two toppings, and no matter what order the toppings are in, if it's the same two toppings, it's going to be the same two. So it's a combination. So let's say that we have two types of crust. So n would be 2, and we can only get to choose one. So combination 2, 1 times combination of 2 out of 3 toppings. So we have 3 total toppings, and we're only taking 2. So we have to go back to the formula for how to do combinations, which is right here. So in the first one, we'd write 2 factorial because 2 is the n, over r, which is 1, so 1 factorial, and then n minus r. N minus r, so 2 minus 1 factorial. Pretty simple. Now we have the other one. So plugging this back in, 3 is the n, so 3 factorial over 2 factorial, parentheses 3 minus 2 factorial. And these are being multiplied together. So simplifying the first one, we get 2 factorial over 1 factorial because 2 minus 1 is 1 and 1 factorial is 1. Times 1 is 1. So this is 2 over 1, which is 1. So this one, 2 over 1 is 2. So this one equals 2. Now, this one's a little more complicated, so we're going to write this out. So 3 factorial is equal to, over 2 factorial, 1 factorial. So 3 times 2 factorial over 2 factorial, 1 factorial. So you cross out the 2 factorials, and you're left with 3 over 1 factorial, or just 3 over 1. This equals 3. So going back to the problem, 2 times 3 equals 6. So you can have so there are 6 different pizza varieties if you have 2 choices of crust and 2 out of 3 possible toppings. That's really all there is to it, to permutations and combinations. If you guys have any more questions, please let me know, and I'll see you guys. Thank you.